You have a unique light signature that is you, but you're not really that color, right? You think that you're the color that you are, but actually that's just your reflection color. You have a whole nother spectrum of you that's the absorption. So let's take an example of hydrogen. This is what the spectral reflection of hydrogen looks like. So if you looked at, spectral analysis of hydrogen, it would have a color purple, another color that's more violet, and then kind of this bluish color, and then this light blue, and then this red pinkish color. Mm-hmm. Right. That combination of colors is how we know hydrogen exists. So when we look into outer space and we use a telescope that does this spectroscopy, and we could see across the entire cosmos, we know where hydrogen pockets are, where there's a high preponderance of hydrogen based on the color reflections that come out. Like if you're looking at some material, you don't know what the material is, you can look at a spectral reflection analysis and be able to tell exactly what that material is just based on the colors that are reflected. There's never been another DNA like yours, and there never will be another DNA identical to yours. Even though you're 99% the same as a monkey, that 1% that makes you different makes you infinitely different. So that means that you have a persona, right, which would be these colors right here, your reflection, and then you have a shadow, which that shadow would be the exact opposite. So all the colors that are used for the reflection are not part of the absorption. That's why you have blacked out lines here. So that means you have all the rest of the colors in the light spectrum that are not you. You perceive they're not you. Well, what if those colors simply get projected back to you as reflection in the world around you? The mathematics of this is something called the Rydberg formula. And Niels Bohr, who was a famous Danish physicist in the 1930s and 40s, who worked closely with Einstein, he was more on the quantum physics side of things. He basically found that you could exactly predict, based on the frequency of hydrogen, its spectral emission of color. And it was exactly accurate. And this is called the Bohr atom model. And the mathematics of it is simply x and 1 over x. So they used here lambda. So it's lambda and 1 over lambda. So you have this differentiation that would then tell you these specific nanometers of light would be converted directly from the spectral or frequency rather of hydrogen, which then I can derive to know exactly and predict exactly based on the frequency of hydrogen, based on its 1 over x calculation, what its nanometers of light signature will be. We have 89 octaves or 88 octaves of experience across sound, thought at the very basis, becomes sound, becomes microwave, it becomes infrared, becomes ultrasound, and then as it goes higher and higher, light is just the 55th octave above sound. So you just keep taking up to higher and higher octaves of frequency, and now you're in the terahertz frequencies, right? So what happens is you just go all the way up until the 55th octave. The 55th octave from the very beginning is light, and that's the only octave of visible spectrum.
Gotcha.
Beyond that are all the other octaves. Then you get into cosmic rays, gamma rays, etc., right? It goes X-rays, all that. So what happens is this visible light spectrum is the same as looking at a piano keyboard, and it's just the note G on the piano keyboard, middle G, because that's the 55th note on a piano keyboard, which is a Fibonacci number. So basically, you look at the piano keyboard, you've got the entire spectrum as a microcosm, right? Which then we can expand and just put lots and lots of 88 piano keyboards next to each other. And the 55th one is the one that yields light. And the other ones are not yielding light, but they're yielding different forms of sound that we have different senses to be able to sense. And the ones we can't sense, we can sense through the pineal gland. You've got a field of little nodal points that are cubes. Each of these cubes has a little LED inside of it. Think of it like an LED. And there's an on excitation and an off excitation. So the opposite condition of light is the off excitation. The condition of light is the on excitation. It's a field, right? And it's just like a gigantic LED screen in 3 dimensions or 4 dimensions or multi-dimension. Or maybe to take it to another mind-blowing level, what's happened is the pixels that you thought were you are not actually you. They're just reflecting the light signature of you. And as you move to another place, it's just like the wave transitioning. You move to another position, then a whole new set of pixels have been on excited to represent your light signature. Just as if you're in a screen on a TV. You're not actually moving. What's happening is that there's a whole new set of pixels that are reflecting you. The only limitations that exist, therefore, are the ones that you persistently believe in, including time. The world around you is just your spectral absorption being reflected back to you, and you're X, and the world around you is your 1 over X. That's why I call it the U inverse.